Hey guys, I'm going to try to keep this video under 15 minutes because of YouTube restrictions, so let's go ahead and get started. I promised you last semester that we were going to do parabolas more in depth this semester, and last semester we used to just kind of like wing it, but now you're actually going to tell me in depth how wide this parabola is going to be with a very exact number of points. But the very first thing that I want you to notice is that last semester the equation of a parabola looked like this. Well, this semester it looks like this to kind of match with the other conics that we've been doing. So what's the difference here? Why, like, what's so different about it? Well, if you'll notice, all I've really done is I've moved k to the other side. So hence it is now subtracted. Now you'll also notice that a has been replaced. A is now 1 over 4p. Well, what is p? P is this like focal length that you're going to now use to tell me how wide the parabola is. So from the vertex of a parabola, 1p distance in is going to be the focus of the parabola. Now there's a very good application of this if you're looking at physics lenses and you're looking at a beam of light coming in. If you want to focus that beam of light onto one point, you can do so with lenses very much like this parabola. Now in the other directions, on each direction, you're going to find 2 points that are going to describe how wide this parabola is. They are 2p distances away from the focus. So 2p or not 2p. But in the other direction is going to be this line that we call the directrix. Now basically what that's doing, also 1p distance away from the vertex, is directing the parabola away from it. It's saying no, open that way. Also another difference that you'll see from last semester is that you now have an equation of a parabola where the y is squared. So these guys look left and right instead of actually up and down like you're used to. So I would like you to draw yourself 4 quick graphs just to kind of like distinguish what's going to happen here. You are very used to having a parabola that opens up, right? In this case, x is squared, and whatever number a that was in front of the squared term is positive. You have a negative. Well, just like that, you're going to have parabolas that open right and open left. Notice that's what's different about the equation, is that y is squared now instead of x. Well, much like up is positive and down is negative, right is positive and left is negative. Everything is pretty much what you're going to expect it to be. If this isn't really making sense to you yet, that's totally fine. I think it will once we get to an example. So go ahead and turn to 1, 2, and 3 on the back of your paper. Now what I want you to do starting every problem is draw yourself a mental picture, because that's going to help you when you're actually graphing. Your mental picture here should tell you, hey, since y is squared, this is going to be a left and right kind of parabola. And not only that, because this is negative, that means that it's going to be facing left. So you want to draw yourself the mental picture that whatever you draw is going to have to look like this. Like this. Sorry, autofocus. Okay. Well, just by looking at this is going to be very similar to your conics. It's going to be a vertex just where you expect. X is 2 and y is -5. Notice how you are switching the sign on both numbers. Now you're going to go over here to 2, -5. You're going to draw yourself a vertex, and from that vertex in the direction that you expect, you're going to draw a focus. Now how in the heck do you find that focal distance p? Well, notice how this used to be a for us, whatever number's in front of the square term. So identify what number you have in front of the square term, and you're always going to set that equal to 1 over 4p. Well, from there, you can cross multiply and see that 4p is 16. So p, this focal distance, is going to be 4, which means that in the direction that my parabola is going to open, I'm going to go 4 squares. Now, what the heck does that focus to? Well, it tells you how wide your parabola is. You're always from the focus going to go 2p lengths away from that focus in either direction. So 2p lengths here is going to be 8, right? Because p is 4. So you're going to go up 8, 6, 8, okay, and you're going to go down 8, about ish right there. So that tells you very exactly how wide your parabola is. And you'll notice this guy is pretty wide. So this guy right here is your focus. And in the other direction, remember, you are now going to start writing 2, 3, 4, a line that we're going to call the directrix. So where is the directrix? Well, that is at x is equal to 6. The focus, you can just count. This isn't like ellipses. I have mine at -2, -5. And the axis of symmetry is the only thing here that's kind of just review of last semester. You're really just going to look at what cuts this little parabola guy in half. So what does cut this little parabola guy in half? Well, it looks like the line is there at y is equal to -5. So there is your axis of symmetry. So let's go ahead and do one that's nice and vertical up and down. This next one, again, draw yourself a mental picture. For this next one, x is squared, which is, it's a very traditional up-down parabola. And because it's negative, that means that it's going to be down, right? So again, the vertex is very much what you expect, but you have to be careful of order. The x is right here, the y is right here. Make sure you put them in x, y order. So this is going to be 8, 4. You're going to go to 8, 4 and draw yourself a vertex. And you have to find this magical focal length p. You're always just going to take whatever number is there. That's your A. You're always going to set it to 1 over 4p. And the only way that this works is if p is 1. Sometimes you can just look at them. So you're going to find that p is 1. So that's a very tiny focal length. That means in your mental picture that this guy goes down. You're going to go from your vertex. You're going to go 1 p length down. And from there you're going to go to p or not to p. And again, that tells you how wide this guy is. This one wasn't as wide as the last one. So you just found your focus. And in the other direction, 1 p length away is going to be your directrix. So your directrix is going to happen at what looks like y is equal to 5. Your focus, if you just count, looks like it's 8, 3. And your axis of symmetry, well, what cuts this guy in half? That looks like it happens at 8. So x is equal to 8. Alright. All of these are nice and fine and dandy. But y'all know that whenever I show you a conic, I show you the most basic conic, and then I show you a conic that you're going to have to complete the square with. So your number 3 should not match this number 3. Your number 3 should look like y squared is equal to 8x plus 6y plus 7. And what you're going to do for anything where it's not a nice little parentheses in a standard form for you is you're going to complete the square like I've already said. But what you want to do is first you want to group the squared variable on one side. So what I'm going to do is I'm going to move everything with y to the left hand side and leave a little bit of wiggle room and have 8x plus 7. So now your task is actually very simple. All you have to do now is complete the square with this left hand side. So you get negative 6 over 2, negative 3, square that, plus 9. So you add 9 to one side, add 9 to the other. And if you notice, you now have the nice little parentheses that you are used to expecting with this kind of problem. But there's two things that are different from the form that we just did. So notice how usually I have the squared term on the right hand side, and in front of the letter that's alone there's usually just a 1. So what I'm going to do is I'm going to make it look exactly like that. I'm going to take my squared term and I'm going to put it on the right hand side. And I want to make that a 1. So you guys are probably seeing already that you can take out an x. And if you divide both sides by that number, you can rewrite it to look like your pretty little parabola equation. Notice how I wrote it as a fraction, just because I expect to set it equal to 1 over 4p. Well, now it's very easy to see that my vertex is at negative 2, 3. My value of p, well, what's my mental picture here? The y is squared, so this is going to be a left-right. There's no negative sign in front, which means that this is going to face right. So my mental picture is that this guy is going to look somewhat like that. So now when I find p, I know what direction to go in from the vertex. Well, I have that 1 over 8 is a. I always set it equal to 1 over 4p. Well, the only way that is true, how is 1/8 1 over 4p, is if p is 2. This is pretty good mental math. So you're going to go to p is equal to 2. And again, your mental picture tells you you're going to go to the right for a focus. And remember, you always go 2p distances. So in this case, 2 times p is 4. So you're going to go up 4 and down 4. And that's going to tell you the exact width of your parabola. Now don't forget, crucial to this graph is also the directrix. It's almost like one of our little totes that we used to have in rational functions. So here's my directrix. And that seems to be at x is equal to negative 4, with a focus at 0, 3, and an axis of symmetry. Just look at where it cuts in half. That seems to happen at y is equal to 3. That's it, you guys. That's parabolas. I think that they're pretty easy. I hope that you guys are doing good. I miss you. Bye.